Guys, we're going to go through page 3 now. Just another little plug to watch the video comparing the difference between compound interest and simple interest. Please, you'll have a much better understanding of it if you watch that first. Okay, before we get into compound interest, it's really important that we can increase or decrease amounts using decimal multipliers. Okay, so this might be to do with increasing by percentages and stuff. And you might have been able to do that by finding 10% or 1% and adding it back on and things, but that method is really going to slow you down and actually probably just make this impossible, this topic for you. So you need to understand the decimal multiplier method. Okay, right, number 1, write down the decimal multiplier used to increase an amount by 10%. So when we increase 100% by 10%, we've now got 110%, which is 1.1 as a decimal. Okay, so remember 110%, 1.1. If we increase 100% by 12%, we've got 112%, which is 1.12. If we increase by 5%, we've got 105%. It's so easy, this method. So that is 1.05. We're just dividing by 100 to turn a percentage into a decimal. If we increase by 3.5%, we've got 103.5%. So the decimal, when we divide that by 100, is 1.035. Okay, multiply something by that, you will increase it by 3.5%, and you don't need to do any adding at all. Okay, the multipliers used to decrease these amounts, what we would do is take these off 100%, that would leave 90% if we took away 10%, which is 0.9. If we took off 12%, that would leave 88%, which as a decimal is 0.88. If we took off 5%, that would leave 95%, which is 0.95. If we took off 3.5%, that would leave 96.5%, which is 0.965. Okay. When we're decreasing an amount, we will always be multiplying by 0 point something. Right. Annie and Ben are both given £100 to invest in a savings account. They see the following adverts. We've got a 4% simple interest account per year and a 4% compound interest account per year. So this is a good question to compare the differences between simple and compound interest. Annie invests her £100 in the HSBC account. Ben invests his in the NatBest account. How much does each person have at the end of 3 years? So if you just come from doing the page on simple interest, let's start with Annie. She is going to earn 4% of £100. So to work out what that is, you would times 100 by 0.04. We're not trying to, well, we are trying to increase it by 4%, but because this is 3 years, we can't just times by 1.04 and then times by 3. We've got to work out what 4% is and times that by 3. And that will work out how much interest Annie gets. Okay, so let's figure out what that is. So that's £12. And then if we add that back on to the original 100, Annie earns £112. Ben, on the other hand, is going to get 4%, but I'm going to use the multiplier to increase his amount by 4%, because I can then just do that again. So what the difference is, after the first year, he will have £104, and it's then that I will multiply by 1.04. So this is the difference between simple and compound. Compound starts with the amount you finished the previous year with. So he then has £108.16. We start year 3 with that amount. Excuse me. And often with compound interest, you might have to do some rounding because it won't be a real amount of money, or not a possible amount of money. Okay, yeah, so we've got now £112.49 when I round it. Okay, so you can see you get slightly more with compound interest than you do with simple interest. Okay, I'm going to show you a shortcut for this. And really, we didn't need to press equals at each stage here. I could have just done 100 times 1.04 times another 1.04 times another 1.04. And I'll show you a quicker way to write that in a moment. Okay, Paul leaves £4,000 in the bank for 2 years. It earns compound interest of 5% per year. Calculate the total amount Paul has in the bank at the end of the 2 years. So here's just a slightly sped up way of doing it compared to the previous question. 4,000 times 1.05, because we want to increase it by 5%. But 2 years, I could do that twice in a row. I don't have to press equals at this stage and find out what that is and then times by 1.05. I could just do it all in one go. Okay, let's see what that gives us. £4,410. Now, an even quicker way to do it is to think about a quicker way of writing that. So that is 1.05 to the power of 2. Okay, and if we use that, we will get exactly the same thing. So here's a really quick way to do it. You take your original amount, you multiply by the interest multiplier to the power of however many years or however many times the interest is applied. So let's apply that on the next question. Population of birds on an island is estimated to increase by 10% every year. Population of birds on the island is 20,000. Calculate an estimate for the population of birds in 3 years' time. So we're going to take our original amount, this doesn't have to be about money, we're going to multiply it by our multiplier. So if we're increasing by 10%, the multiplier will be 1.1. To the power of however many times this is going to happen. So this is every year, and it says in 3 years' time. So to the power of 3, let's see what we get. 26,620 birds. Okay. Number 6. The value of a car decreases by 5% each year. Sophie bought a car 2 years ago for £10,000. Work out the value now. So we can do the same with decreases. Now the multiplier on a decrease, if I want to decrease something by 5%, that would be 0.95, because I'd be left with 95% of the value. So I'm going to multiply by 0.95, and that would be after 1 year, but then I would do that again, or I could just raise that to the power of 2, because it's 2 years. So the car is now worth £9,025. And this has a special name. It's not just compound interest in reverse or anything like that. It's called depreciation. You might have heard of it. And the last one, Sam invests £1,800 in the bank for 4 years. It earns compound interest of 4% each year. Calculate the amount Sam has at the end of 4 years. So, straightforward. I'm going to increase it by 4%, so 1.04. So the multiplier to the power of 4 years. Just got to watch out for questions that ask how much interest had been earned, rather than how much do they have altogether. So for this one, Sam has now got £2,105.75. And this is one where we've had to round it slightly. Just going to check I read all the other questions properly. Yep, okay. Right guys, thanks for watching.